The James Webb Space Telescope has made a significant breakthrough in providing us with an unprecedented view of the universe. On this occasion, it has gone deep into the depths of the famous supernova SN 1987A. This telescope has revealed new structures that had never been seen or observed by previously telescopes. When the star exploded in 1987, it became the brightest supernova visible from the Earth in nearly 4 centuries. SN 1987A lies at a distance of about 170,000 light-years from us. Located in the Large Magellanic Cloud, a dwarf galaxy close to our own Milky Way. The new image captured by the telescope uniquely shows the structure of the center of the supernova remnant, which is shaped like a keyhole in shades of blue. Join us on this 170,000 light-year journey to the Large Magellanic Cloud to discover all the details of the core of supernova SN 1987A. The core of the supernova is composed of gas and dust ejected by the supernova explosion, and the dust is so dense that even infrared light detected by the telescope cannot pass through it, creating a dark keyhole. Inside the keyhole, we find a bright equatorial ring that forms a band around the central region and connects 2 faint hourglass-shaped arms. This equatorial ring was formed from the debris ejected tens of millions of years ago before the supernova explosion and features bright spots that emerged when the supernova shockwave impacted against it. According to the information provided by NASA, the bright spots that had been detected were formed when the shockwave generated by the supernova explosion impacted the equatorial ring of gas that the stars had ejected several tens of millions of years before its explosion. These bright spots can now be detected even outside the main ring, emitting light diffusely into their surroundings. These areas are where the collisions between the shockwave and the outer material take place. In addition, the Webb telescope has revealed additional crescent-shaped structures which had gone unnoticed in earlier observations with the Hubble Space Telescope. NASA suggests that these crescent-shaped formations are the outer layers of gas ejected during the supernova explosion. NASA, in its press release, mentioned that despite decades of studies since the initial discovery of the supernova, several mysteries remained unsolved, especially regarding the information of neutron stars that should have originated after the supernova explosion. The space agency also notes that the James Webb Space Telescope will continue to observe the supernova in the future. The James Webb Telescope has identified another dying star in the Saturn Ring Nebula, which also shows intricate structures corresponding to the final stages of a star's life. This nebula is bright and lies at a distance of 22,000 light-years from Earth, making it visible with binoculars on clear summer nights in both the northern and southern hemispheres. This observation should not be confused with one of the first images captured by the James Webb Space Telescope. The international collaboration known as SNs, consisting of experts from several countries with expertise in planetary nebulae and other related objects, recognize the importance of making observations over the network to obtain essential information. In particular, the Ring Nebula was identified as an ideal target because of its perfect fit in the field of view in the mid-wavelength infrared camera aboard the James Webb Space Telescope. This choice allowed the nebula to be explored at an unprecedented level of spatial detail, which in turn helped to unravel some of the mysteries surrounding planetary nebulae. Thanks to its array of infrared sensors, James Webb was able to capture images that offer exceptional spatial resolution and spectral sensitivity amid the cosmic chaos. According to the release, this means that the telescope, located at a distance of approximately 1 million miles, 1.6 million kilometers from Earth, was able to reveal previously unseen details of the nebula's intricate structure. When scientists first observed the images, they were astonished by the abundance of detail they revealed. The bright ring that gives the nebulae its name is composed of about 20,000 individual clusters of dense molecular hydrogen gases, similar to what we find on Earth. Within the Ring Nebula, a narrow band of emission containing protocyclic aromatic hydrocarbons and complex carbon molecules is found. This finding is surprising, as we did not expect to find these molecules in the Ring Nebula. Outside the bright ring, we observed particular peaks extending in opposite directions from the central star. These peaks are especially prominent in the infrared spectrum, but are not as evident in visible images captured by the Hubble Space Telescope. It is believed that these peaks may be related to molecules that have the ability to form in the darker, denser areas of the ring. In these areas, the molecules will be shielded from the intense direct radiation emitted by the hot central star. This includes a capture of infrared light, which is invisible to the human eye. The James Webb Space Telescope provided detailed information on the structure of the ring filaments, as well as the presence of approximately 10 concentric Rs in the outermost regions of the nebula. These target-shaped Rs were a surprise, suggesting that they formed about 280 years ago, when the central star was shedding its outer layers during the transition to a planetary nebula. This time period is unusual and no known process can explain it. Instead, the presence of these rings suggests the possible existence of a companion star in the system, orbiting at a considerable distance from the central star, similar to the distance between Pluto and our Sun. As the dying star expelled its atmosphere, the companion star may have influenced the formation of these rings. Roger Wesson of Cardiff University offered an explanation for this phenomenon, nothing that no previous telescope had the sensitivity and spatial resolution capability to discover this subtle effect. Importantly, this is not the first time the James Webb Space Telescope has looked at the Ring Nebula, indicating the continuing importance of studying this intriguing phenomenon. The history of the Ring Nebula represents a symbol of human curiosity and scientific progress. From its early misinterpretations as a planetary nebula to the advanced technology of the James Webb Space Telescope, our quest to understand this phenomenon has closely followed the development of astronomy. The Ring Nebula was discovered in 1779 by astronomers Pierre Méchain and Charles Messier, who included it in their Messier catalog while attempting to track a comet through the constellation Lyra. Today, this nebula has become an emblem of astronomical archaeology. Its distinctive brightly colored ring represents the remains of a dying star on its way to becoming a white dwarf, acting as a striking reminder of our cosmic connection. In studying the Ring Nebula, we're not only observing a distant object, but we're exploring the past, present, and future of the universe itself. We may even consider that our Sun, in about 5 billion years, could give rise to a similar nebula at the end of its life, although it is unlikely that we will be around to witness it. It is important to note that the color differences in the images of the same nebula may appear strange. This is because the James Webb Telescope observes objects at infrared wavelengths, which are invisible to our eyes. The original Webb images appear black before the image processor translates them into visible light wavelengths, which highlights certain aspects of the nebula in each image. The James Webb Space Telescope, with its ability to explore everything from the deepest views of the universe to the rings of planets in our own solar system, is giving astronomers an exciting new perspective on space. The question arises, what discoveries does the future hold with the James Webb Telescope? Let us know in the comments box what discoveries you would like the James Webb Telescope to make. If you liked the video, remember to hit the like button and subscribe to the channel. And I'll see you in the next one. Thank you so much for watching.